Hello, my name is John Hooker, and today we're going to talk a little bit about our digital oil field, specifically our virtual well test with our OptiRamp software. So, like I said, I'm John Hooker. I'm the engineering director of Statistics and Control Inc. here, and I've been with the company for about 13 years. To explain just a little bit about our company, what we do is we are actually an engineering and consulting technology company. We have a lot of people here who have 30, 40 years in especially the turbo machinery control experience, as well as in digital oil field solutions and simulation. So we contract on projects with companies located all over the world. We have quite a lot of different services and solutions that we provide across a lot of different sectors. And one of the things that kind of sets us apart from a lot of people is that our technology is highly customizable and we own all of our software solutions. So, like I said, we're all across the world. We have our headquarters here in West Des Moines, but we have integrated offices all over the place that have been there for several years, or some just pop up. So, we get around to South America, Europe, Africa, Asia, Southeast Asia. Like I said, if we have an office there, we normally have done a project there. But today we're going to focus a little bit on our OptiRamp virtual well test. And basically, the OptiRamp virtual well test, the whole purpose of it is to be able to take that data that comes in infrequently, like those well tests, and be able to model the behavior that's coming from those live signals that we have in the field. So the whole purpose is to model the reservoir and each individual well, and then be able to have that continuous well analytics on there and auto-tune the wells to help give those deliverability characteristics without any human intervention, and being able to have at least a 1% accuracy in the calculations that we're having. And from there we can do well performance trend analysis, take a look at what's happening in the future, look at computed versus tested well flows also. So the whole purpose behind this implementation is to characterize the wells to determine how much wells are producing from each source. As I said, wells are rarely heavily instrumented, and it's hard to put flow meters on each and every single one, and also very expensive. And so what a lot of reservoir engineers and what a lot of operations people do is they push for more well tests to build performance curves to determine that oil, water, and gas that are coming from each individual well. Well, what our software OptiRamp can do is we can take that well test and turn it into a virtual well test. We take those erratic well tests and help build those performance curves for each well to where you can have live signals for each ones. And how do we go about doing that? We basically take the tubing head temperature or pressure, we take the flow line pressure that is coming in live data, and then if there's any artificial lift on it, so for gas lift wells, we want to have gas lift flow rate. For submersible pumps, we want to have pump intake, pressure, or power. And for progressive cavity pumps or rod pumps, we want to have the speed on them. And then we want to have those erratic well tests or those infrequent well tests. And then any fluid sampling that you do out in the field. And then somewhere downstream, you normally have a custody exchange of total oil, total water, and total gas that are coming out. And so with those inputs, we can get outputs for each and every single individual well of a water cut, oil gas ratio, and the flow of each phase in that individual well of gas flow, oil flow, water flow. And then we can also get the pressure and temperature of each one, as well as the fluid density of each phase. And if you have artificial lift, we can also look at the oil production change or liquid production change that happens when we take into account our optimization algorithms. So here's just going through a quick example of a virtual well test. We have two wells, well A and well B, and basically in this example you can see that the blue marks are the water flow, the black marks are the oil flow, the red marks are the gas flow. And data processing, these well tests can come infrequently. They can come once a week, once a month, once every 2 months. It doesn't matter. Our data processing time can be shorter or longer as necessary with however many flow tests that are coming in, or well tests that are coming in. And basically the whole idea is to help fill in those gaps in data with a virtual well test. And so basically what we're able to do is if one well has 3 tests and any of the other wells have at least one test, we can fill in those virtual well tests in for all of them. In this instance, the virtual well test looks like it's just about every 2 hours. So it can change based on how often we get live data in and how often well tests come in. So a great example of how we determine the phase flow for each one is we create the oil, gas, water flow for wells A and B. These are 3 independent variables for each well test, and over 150 independent variables over just this 2-day time frame. So being able to solve that takes quite a lot of number crunching in there. And the way that we do that is we actually base that off of material balance. Where we have a series of computations, we balance the material, and then we use multi-phase equations of state to help solve for those flow rates under critical or non-critical conditions in there. And also having live data on the well tests, or I'm sorry, live data on the artificial lift systems help determine the characteristics of that whole flow. So now that we have those virtual well tests and we can calculate them once every hour, once every 2 hours, however often that you want, we can then start doing quite a lot of fun things with those calculations. So one of the main points being forecasting and analysis. So the whole idea is to track that oil production, track the flow production and water cut and efficiency of a well. And especially if you have a lot of wells out there, it's very hard to be able to maintain and combine and analyze all of this data, where the whole purpose behind our software is to help show specific conditions that are happening in the field. So a great example is this is a decline rate for a oil production well, and we can do the oil production rate of it and predict that value and how much it's going to either raise or lower 90 days out. And then another thing we can also do is take a look at the flow production, and so we can tell, okay, this well is going to be acting in this way 30 days out from now, to where it helps with maintenance and it helps with your operations team to track and maintain what's going on with each individual well, and be able to help create a schedule to where we tackle the wells that have the lowest productivity, the most decline in production, or even ones that are performing under what our targets are in there. And so it's basically just a way to help analyze the field and what's going on in there. So there's quite a lot of opportunities with virtual flow measurement. One of the things that we focused on was mostly on the production side, but throughout the entire process, one of the joys of simulation is by being able to have those virtual measurements in there, we can take a look at that production optimization. You can also optimize source streams to help improve pipeline deliverability. The whole idea is in transportation, decrease that pipeline friction, chemical management, reduce fuel consumption for whether it be pumps or compressors, and help manage that mass balance in there. And also take a look at how you're offloading a lot of that system in there as well. So our optimization algorithms really help provide information to meet those obligations that you have in the most economically efficient way, and also help optimization with computing set points for each of these particular aspects of the field, in production, in storage, in the transportation network, as well as in the consumption network. So there's quite a lot of opportunity available when you start being able to get those virtual flow measurements in there, and by getting in virtual measurements in there. Here this just kind of takes a look at the system optimization and how a lot of non-systematic energy management systems go. Is this black line, you see that you have a little bit of a cost increase, and then it starts to dip down at that level 2. And then after that, we start losing those systematic improvements, or the changes that you're doing start going downstream, and it's less effective over time. And especially if it moves downstream and you don't see it, then operations has no reason to change, because there's no motivation for continuous improvement. Whereas if we start looking at the entire approach and systematically split it into those different levels of, okay, let's visualize the losses, let's formalize a process, then you start really getting those sustained savings over time. And so the whole idea is to have that total value stream from wellhead to tanker or refinery, and being able to view those virtual measurements, not have to light up your entire field like a Christmas tree, and be able to know what's going on between point A and point B in your system. By having more of that actionable information can help with maintaining and optimizing the system especially. So thank you for hearing me talk, and now we'll get to the question section of this guy. Thank you.